In the vast asteroid belt between Mars and Jupiter, millions of rocky fragments drift silently through space. Most of them are ordinary remnants from the birth of the solar system, broken pieces of ancient worlds that never fully formed. But one object stands apart. Its name is 16 Psyche. At first glance, Psyche looks like just another asteroid, irregular, heavily cratered, and quietly orbiting the Sun. But when scientists began studying it more closely, they discovered something astonishing. Unlike most asteroids made of rock or ice, Psyche appears to be composed largely of metal, not stone, not frozen water, but iron and nickel, the same materials found deep inside planetary cores. This has led scientists to an extraordinary possibility. Psyche may not simply be an asteroid, it might be the exposed heart of a destroyed planet, the metallic core left behind after violent collisions stripped away its outer layers billions of years ago. If this is true, Psyche could offer the first direct glimpse into the hidden interior of a world, something we can never observe on Earth. Today, NASA is sending a spacecraft to investigate this mysterious object, and what it finds there could completely change our understanding of how planets form. But before we explore this strange metallic world, welcome to Theories Before Sleep, where we slowly journey through the mysteries of the universe, one cosmic story at a time. Between the orbits of Mars and Jupiter lies one of the most chaotic regions of the solar system. It is a vast cosmic field scattered with millions of rocky bodies, fragments left behind from the violent era when the planets were still forming. Astronomers call this region the asteroid belt, and for centuries it has been considered a graveyard of unfinished worlds. Most asteroids are not especially mysterious. They are usually made of stone, carbon-rich material, or frozen compounds mixed with dust. They formed from the leftover debris of the solar system's birth roughly 4.6 billion years ago. Over time, gravity and countless collisions shaped them into the irregular, cratered objects we observe today. But every once in a while, something appears in space that does not quite fit the pattern. Among the millions of asteroids orbiting between Mars and Jupiter, one object has captured the attention of scientists for more than a century. Its name is 16 Psyche. Discovered in 1852 by the Italian astronomer Annibale de Gasparis, Psyche quickly stood out among the growing catalogue of asteroids. At first, however, there was nothing obviously unusual about it. Like many asteroids, Psyche appeared as a faint point of light moving slowly across the night sky. But as telescopes improved and astronomers began measuring its properties more carefully, a strange picture began to emerge. Psyche was not just another chunk of rock drifting through the asteroid belt. It was something far more unusual. Modern observations suggest that Psyche may be composed largely of metal, primarily iron and nickel. These are the same heavy elements that form the cores of rocky planets, including Earth. This discovery raised an extraordinary question. What if Psyche is not simply an asteroid? What if it is the exposed core of a long-destroyed planet? To understand why this possibility is so remarkable, we must first look back to the earliest chapter of the solar system's history. Billions of years ago, the region between Mars and Jupiter looked very different from what we see today. Instead of scattered asteroids, it was filled with countless, growing planetary embryos, large bodies formed as dust and rock, gradually stuck together under gravity. These objects were known as protoplanets. Some of them grew large enough to begin developing internal layers. As heat from radioactive decay and constant impacts warmed their interiors, their materials started to separate. Dense metals like iron and nickel sank toward the center, forming a core, while lighter rocky material floated above it, forming a mantle and crust. This process is called planetary differentiation. It is the same process that shaped Earth, Mars, Venus, and Mercury. Inside our own planet, the core lies thousands of kilometers beneath the surface. No spacecraft or drill could ever reach it. The only way we study Earth's core is indirectly, through seismic waves produced by earthquakes. But Psyche may offer something completely different. If scientists are correct, Psyche could be a planetary core exposed to space. Imagine a young protoplanet forming in the early solar system. Over millions of years, it grows larger and larger, accumulating rock and metal as gravity pulls material toward it. Eventually, its interior melts enough for heavy metals to sink toward the center. The world becomes layered. A dense metallic core forms deep inside, surrounded by thick rock. But the early solar system was not a peaceful place. It was a chaotic environment filled with enormous collisions. Protoplanets frequently smashed into each other at incredible speeds, sometimes destroying entire worlds. If such a catastrophic collision stripped away the rocky outer layers of a differentiated protoplanet, what would remain? Only the core, a massive exposed ball of metal drifting through space. This is the astonishing possibility scientists began to consider when studying Psyche. At roughly 220 kilometers across, Psyche is one of the largest objects in the asteroid belt. Radar observations reveal that its surface reflects radio waves in a way that is highly consistent with metallic materials. Spectral analysis also hints at a composition rich in iron and nickel. These clues suggest Psyche may be very different from the rocky asteroids surrounding it. Instead of being a simple rubble pile, Psyche might represent something much rarer, a direct glimpse into the deep interior of a planetary body. If that idea proves correct, Psyche would be unlike anything humanity has ever explored. Throughout the solar system, planetary cores are hidden beneath thousands of kilometers of rock. On Earth, the core is buried beneath the crust and mantle. On Mars and Venus, the situation is similar. Even Mercury, the planet with the largest metallic core relative to its size, still hides that core beneath its surface layers. But Psyche may have lost those layers entirely. If it truly is an exposed core, then studying Psyche could reveal the composition and structure of planetary interiors in a way that has never been possible before. For decades, astronomers debated this idea. Some believed Psyche must indeed be metallic. Others argued that the asteroid might instead be a mixture of metal and rock, perhaps the remains of multiple bodies fused together after countless collisions. Observations from Earth could only reveal so much. From millions of kilometers away, even the most powerful telescopes cannot resolve the fine details of Psyche's surface. To truly understand what Psyche is, scientists needed to do something more ambitious. They needed to go there. In recent years, NASA launched a mission designed specifically to investigate this mysterious object. The spacecraft is called Psyche, and its journey through the solar system will take several years before it finally reaches the asteroid. When it arrives, it will begin mapping the asteroid in extraordinary detail, studying its surface composition, measuring its gravity, and examining its magnetic properties. These observations may finally answer the question that has puzzled scientists for generations. Is Psyche truly the exposed heart of a lost planet, or is it something even stranger? One possibility is that Psyche formed in an entirely different way. Some researchers suggest it might be a mixture of metallic fragments fused together over billions of years. Others believe it may contain significant amounts of rock hidden beneath a metallic surface. There is even speculation that Psyche could represent a type of object that no longer exists elsewhere in the solar system, a relic from a time when planetary formation was still incomplete. Whatever the truth may be, Psyche is already reshaping how scientists think about the asteroid belt. For many years, the belt was believed to be composed mostly of simple rocky bodies. But objects like Psyche remind us that the region is far more complex than it first appears. It is a museum of ancient history, preserving fragments of the earliest worlds that once existed around the Sun. Each asteroid tells part of that story, but Psyche may hold one of the most important chapters. Because if it truly is a planetary core, then it represents something extraordinary, a piece of a world that was destroyed billions of years ago, leaving behind only its metallic heart, a silent survivor of the violent age when planets were born. And soon, for the first time in human history, a spacecraft will arrive to study that metallic world up close. What it discovers there could reveal secrets not only about Psyche itself, but about the hidden interiors of planets across the solar system, and perhaps even about the formation of our own world. Long before spacecraft explored the planets, and long before powerful space telescopes revealed the distant corners of the universe, astronomy relied on something much simpler: patient observation. Night after night, astronomers scanned the sky with telescopes, mapping the positions of stars and searching for objects that move slowly against the fixed background of the cosmos. These wandering lights were known as minor planets or asteroids, remnants of the early solar system scattered throughout the region between Mars and Jupiter. During the early 19th century, the discovery of asteroids became something of a scientific race. After the first asteroid, Ceres, was discovered in 1801, astronomers across Europe began carefully surveying the skies in hopes of finding more. Within a few decades, dozens of these small worlds had been catalogued. Most appeared similar, faint points of light drifting slowly along predictable orbits within the asteroid belt. They varied in size and brightness, but their nature remained largely unknown. At the time, telescopes were not powerful enough to reveal their shapes or surfaces. To observers on Earth, they looked no different from distant stars. Then, on March 17, 1852, a new asteroid was discovered at the Observatory of Naples in Italy. The astronomer responsible for this discovery was Annibale de Gasparis, one of the most successful asteroid hunters of his time. Gasparis had already discovered several minor planets before identifying this new object. As he tracked the faint moving light across the sky, it was eventually confirmed to be another member of the growing asteroid family. The object was given the name Psyche, after the Greek goddess associated with the human soul. At the time of its discovery, Psyche was simply listed as the 16th asteroid ever found, which is why it still carries the designation 16 Psyche today. For decades after its discovery, Psyche remained little more than a faint dot observed through telescopes. Astronomers could measure its orbit and estimate its brightness, but its true nature remained hidden. In the 19th century, the asteroid belt itself was poorly understood. Many scientists originally believed that the asteroids might be fragments of a single destroyed planet, a hypothetical world that once orbited between Mars and Jupiter before being shattered by some catastrophic event. Later research revealed that this idea was incorrect. Instead of being pieces of one lost planet, the asteroids were the leftover building blocks of planetary formation, objects that never merged into a full-size planet due to the gravitational influence of nearby Jupiter. Even so, the asteroid belt remained a chaotic environment. Over billions of years, countless collisions had reshaped its inhabitants. Asteroids smashed into each other repeatedly, breaking apart and forming new fragments. Some objects were reduced to rubble piles loosely held together by gravity, while others survived largely intact. Within this cosmic debris field, Psyche quietly continued its orbit around the Sun. At a distance of roughly 3 astronomical units from the Sun, about 3 times farther from the Sun than Earth, Psyche travels through one of the outer regions of the asteroid belt. But unlike many of its neighbors, Psyche is unusually large. Its average diameter is about 220 kilometers, making it one of the most massive asteroids known. Although it is smaller than objects like Ceres or Vesta, it is still among the most significant bodies within the belt. Yet Psyche's size alone was not what eventually captured the attention of scientists. The real mystery began to emerge in the 20th century as astronomers developed new techniques for studying asteroids. One of the most important tools was spectroscopy, the analysis of light reflected from an object's surface. By examining how light interacts with different materials, scientists can determine what those materials are likely made of. When sunlight strikes an asteroid, some wavelengths of light are absorbed, while others are reflected back into space. Each type of material produces a unique spectral fingerprint. By analyzing these fingerprints, astronomers can estimate the composition of distant objects without ever touching them. When Psyche's spectrum was studied in detail, the results were surprising. Most asteroids fall into several common categories. Some are carbonaceous asteroids, dark objects rich in carbon compounds and organic materials. Others are silicate asteroids, composed mainly of rocky minerals, similar to those found on Earth. But Psyche did not fit neatly into either category. Instead, its spectral signature suggested something very different. The asteroid appeared to contain large amounts of metal, particularly iron and nickel. These metals are not unusual in the solar system. They are common within planetary cores. Earth's core, for example, is made primarily of iron and nickel, and it extends thousands of kilometers beneath the surface. But finding such materials exposed on the surface of an asteroid was unexpected. Most asteroids are made of primitive materials left over from the early solar system. They have not undergone the intense heating and differentiation required to separate metals from rock. So how did Psyche acquire such a metallic composition? One possibility was that Psyche formed unusually rich in metal from the beginning. But this explanation raised additional questions about how such a body could form in the first place. Another possibility was far more dramatic. Perhaps Psyche was not originally an asteroid at all. Instead, it might be the exposed core of a protoplanet. During the early stages of planetary formation, many protoplanets formed throughout the solar system. These bodies could grow hundreds of kilometers across, large enough for their interiors to heat up and differentiate into layers. Dense metals would sink to the center, forming a core, while lighter rock formed the outer layers. But the early solar system was filled with violent collisions. Some of these protoplanets did not survive intact. If a large impact stripped away the rocky mantle and crust of such a world, the metallic core might remain, and that core could look very much like Psyche. This hypothesis quickly captured the imagination of scientists. If Psyche truly represents a planetary core, then studying it could provide something extraordinary: direct access to a part of a planet that is normally hidden deep underground. On Earth, the core lies about 3,000 kilometers beneath our feet. No human technology could ever reach it directly. Instead, scientists must rely on indirect methods like seismic waves to study its properties. But Psyche may allow us to observe such material directly on the surface. That possibility alone made Psyche one of the most intriguing objects in the asteroid belt. Over time, astronomers continued to study Psyche using increasingly advanced instruments. Radar observations revealed that its surface reflects radio waves in a way consistent with metallic materials. Thermal measurements suggested a dense and solid structure rather than a loose rubble pile. Even its mass hinted at something unusual. Psyche is relatively dense compared to many other asteroids of similar size. All of these clues seem to point toward a metallic composition. However, the story was not entirely straightforward. Later observations suggested that Psyche might not be made entirely of metal. Instead, its surface could contain a mixture of metal and silicate rock. Some regions may even contain volcanic-like features or deposits formed through ancient geological processes. This complicated the original idea of Psyche as a pure planetary core. Instead, Psyche might represent something more complex, perhaps a partially stripped protoplanet or an object formed from multiple metallic fragments that merged together after ancient collisions. In other words, Psyche might not fit into any existing category of asteroid. It could represent a completely different class of object. As scientific debates continued, one thing became increasingly clear: Psyche was too important to study from Earth alone. Telescopes could only reveal so much. To truly understand this strange world, scientists needed to send a spacecraft to investigate it directly. But reaching Psyche would not be easy. The asteroid lies hundreds of millions of kilometers from Earth, deep within the asteroid belt. Any spacecraft would require years of travel and careful navigation to reach it. Yet the scientific potential was too great to ignore. If Psyche truly represents the exposed core of a protoplanet, it could provide the first direct glimpse into the interior of a world. Such a discovery would reshape our understanding of planetary formation across the entire solar system. Eventually, the idea of exploring Psyche transformed from speculation into a real mission. NASA began developing a spacecraft designed specifically to travel to this mysterious metallic world. Its goal would be simple, yet incredibly ambitious: to uncover the true nature of Psyche, to determine whether it is truly the metallic heart of a destroyed planet, or something even stranger. But before that spacecraft ever arrives, we must first understand the chaotic environment that created objects like Psyche in the first place. Because the story of Psyche cannot be separated from the violent history of the asteroid belt itself. And that history is filled with collisions powerful enough to tear entire worlds apart. Long before the planet settled into the orderly orbits we see today, the early solar system was a violent and chaotic environment. Dust, rock, and metal filled the space around the young sun, forming a vast swirling disk known as the protoplanetary disk. Within this disk, countless small particles began colliding and sticking together. At first, the process was slow. Tiny grains of dust clumped into larger aggregates. These aggregates collided again and again, gradually forming kilometer-sized objects known as planetesimals. Over millions of years, gravity pulled these bodies together into larger structures. Some of these growing worlds became protoplanets. Protoplanets were essentially young planets, still in the process of formation. They could range from tens to hundreds of kilometers in diameter, sometimes even larger. As they grew, their internal structures began to change. Inside these early worlds, heat started to build. Part of this heat came from constant impacts with other bodies. Every collision released enormous amounts of energy. Another source of heat came from the decay of radioactive elements trapped inside the forming planet. As temperatures rose, the materials inside these protoplanets began to melt. And when that happened, something remarkable occurred. The internal structure of the world began to reorganize itself. Heavy metals like iron and nickel sank toward the center, pulled inward by gravity. Meanwhile, lighter materials, such as silicate rocks, rose toward the outer layers. This process is called planetary differentiation. It is the same process that shaped the structure of Earth, Mars, Venus, and Mercury. Today, our own planet has a layered structure, a dense metallic core surrounded by a rocky mantle and crust. But during the early solar system, many protoplanets began this differentiation process without ever becoming full-sized planets. Some of them never survived long enough. Because the early solar system was also a place of incredible violence, protoplanets frequently collided with one another at enormous speeds. These collisions could reshape entire worlds in a matter of minutes. Sometimes, two protoplanets merged together to form a larger body. Other times, the impact was so powerful that both objects were shattered. These catastrophic collisions played a major role in shaping the solar system we know today. In fact, scientists believe that Earth's moon formed after a massive collision between the young Earth and a Mars-sized body called Theia. The impact blasted debris into orbit around Earth, eventually forming the moon. Events like this were common in the early solar system. In the region between Mars and Jupiter, many protoplanets likely began forming but never completed the process. the strong gravitational influence of Jupiter prevented them from merging into a single large planet. Instead, they remained trapped in a chaotic environment where collisions continued for hundreds of millions of years. Over time, many of these bodies were shattered. Their fragments became the asteroids we see today. But what would happen if one of these protoplanets had already differentiated into layers before it was destroyed? Imagine a young world with a metallic core surrounded by thick, rocky layers. Then imagine a massive collision powerful enough to strip away those outer layers. The rocky mantle and crust might be blasted into space, but the dense metallic core could survive. If that core remained largely intact, it would become something extraordinary, a planetary core exposed directly to space. For decades, scientists have wondered whether Psyche might be exactly such an object. If Psyche truly is the exposed core of a destroyed protoplanet, then it represents something incredibly rare. Throughout the solar system, planetary cores are normally hidden deep beneath layers of rock. Even on Mercury, the planet with the largest metallic core relative to its size, the core remains buried beneath hundreds of kilometers of crust. But Psyche may be different. Instead of being hidden underground, its metallic interior may be sitting openly on the surface. This possibility makes Psyche one of the most scientifically valuable objects in the asteroid belt, because studying it could allow scientists to observe the structure and composition of planetary cores directly for the first time. But how likely is this idea? Over the years, astronomers have gathered multiple lines of evidence suggesting that Psyche might indeed be metallic. One of the most important clues comes from radar observations. When radar waves are transmitted toward an asteroid, they bounce off the surface and return to Earth. The strength of this reflection can reveal important information about the material covering the asteroid. Metal surfaces reflect radar waves very strongly. Rocky surfaces, by contrast, tend to scatter the waves more weakly. Observations of Psyche have consistently shown unusually strong radar reflections. This suggests that large portions of its surface may contain metallic materials. Another clue comes from density measurements. By observing how Psyche interacts gravitationally with nearby objects and measuring its size, scientists can estimate its average density. Psyche appears to be significantly denser than many other asteroids. This supports the idea that it contains a substantial amount of metal. However, the picture is not perfectly clear. Recent observations have also suggested that Psyche may contain a mixture of metal and rock. Some regions might be dominated by metallic materials, while others could contain more traditional rocky minerals. In other words, Psyche may not be a completely pure metal object. Instead, it might represent a more complicated structure. One possibility is that Psyche formed as the core of a protoplanet, but later accumulated additional rocky material after the original collision. Another possibility is that Psyche formed from multiple metallic fragments that merged together after several ancient impacts. These scenarios are still being debated by scientists, but regardless of its exact origin, Psyche clearly represents something unusual. It is one of the largest M-type asteroids, a class of asteroids believed to contain significant amounts of metal. M-type asteroids are relatively rare compared to the more common carbonaceous and silicate asteroids found in the belt. Studying Psyche could therefore reveal important information about how metals were distributed throughout the early solar system. But perhaps the most fascinating aspect of Psyche is what it might tell us about planetary interiors. On Earth, the metallic core generates our planet's magnetic field through the movement of molten iron deep beneath the surface. This magnetic field protects Earth from harmful solar radiation and helps make our planet habitable. Scientists have wondered whether Psyche might once have possessed a similar magnetic field. If Psyche was once part of a larger protoplanet with a molten metallic core, it may have generated a magnetic field billions of years ago. If that field left traces within the asteroid's metallic materials, scientists might be able to detect it. Such a discovery would provide remarkable insight into the early history of planetary magnetic fields. It could also help scientists understand how common differentiated protoplanets once were in the asteroid belt, because Psyche may represent only one survivor of a much larger population of early worlds that no longer exist. Billions of years ago, the asteroid belt may have contained many differentiated bodies, each with their own cores, mantles, and crusts. But repeated collisions gradually destroyed most of them. Their fragments were scattered throughout the solar system. Only a few rare survivors like Psyche may remain. If this is true, then Psyche is not just an asteroid. It is a fossil from the age of planetary formation, a relic from a time when entire worlds were still being built and destroyed within the young solar system. And that is precisely why scientists are so eager to explore it, because somewhere beneath its cratered metallic surface may lie the story of a lost planet, a world that once existed billions of years ago before being shattered by cosmic violence. A world whose metallic heart may still be drifting through space today, waiting for us to finally uncover its secrets. From millions of kilometers away, Psyche appears as nothing more than a faint point of light drifting slowly through the asteroid belt. Even the most powerful telescopes on Earth cannot reveal its surface in fine detail. To us, it remains distant and mysterious, a tiny object hidden among countless others orbiting between Mars and Jupiter. But scientists have spent decades trying to understand what Psyche might actually look like. If Psyche truly contains large amounts of metal, then its surface may be unlike anything we have ever seen before in the solar system. Most asteroids are rocky. Their surfaces are typically covered with loose material known as regolith, a mixture of dust, gravel, and broken rock created by billions of years of impacts. These surfaces tend to be dull, uneven, and coated with debris, but a metal-rich asteroid could behave very differently. Iron and nickel respond to impacts in ways that rock does not. Instead of simply shattering into dust, metal can deform, bend, or fracture in unique ways, depending on the force of the collision. Over billions of years, this could produce a landscape that looks quite different from the rocky worlds we are familiar with. Astronomers believe Psyche's surface may be covered with massive craters formed by ancient impacts that occurred throughout the history of the asteroid belt. The asteroid belt is one of the most collision-filled regions of the solar system. Although the objects within it are spread over a vast area, gravitational disturbances constantly shift their orbits. When two asteroids cross paths, the results can be catastrophic. Over billions of years, Psyche has almost certainly been struck thousands of times. Each impact would have blasted enormous craters into its surface. Some of these craters may be tens of kilometers wide. Others might be even larger. But unlike rocky asteroids, Psyche's metallic composition could influence how these craters formed. When a meteor strikes rock, the material tends to break apart easily. But metal can absorb energy differently. It may fracture into jagged formations or even create unusual structural patterns around the impact site. This raises the possibility that Psyche's craters might have steep metallic walls, fractured ridges, and unusual surface textures. Some scientists believe that portions of Psyche's surface may even resemble enormous metallic cliffs rising above the surrounding terrain. Imagine standing on the surface of such a world. The ground beneath your feet might not be loose dust or broken rock. Instead, it could be a hardened metallic landscape, a frozen record of ancient impacts etched into iron-rich terrain. Of course, Psyche is not expected to be a perfectly smooth metal sphere. Even if it originated as a planetary core, billions of years of collisions would have dramatically reshaped its surface. Large impacts may have cracked the metal, exposed deeper layers, and scattered debris across the asteroid. In fact, some regions of Psyche may contain rocky material mixed with metal. If the asteroid once belonged to a larger protoplanet, fragments of the original mantle or crust could still remain on the surface. These rocky deposits might appear as darker patches scattered across the metallic terrain. Another possibility is that impacts from other asteroids delivered additional material to Psyche over time. Dust and debris from surrounding objects could have accumulated on the surface, creating a thin layer of mixed rock and metal. This combination of materials may explain why some observations suggest Psyche is not purely metallic. Instead, its surface could be a complex mixture of metal-rich regions and rocky deposits, a patchwork formed through billions of years of impacts. But there is another fascinating possibility that scientists have begun to explore. What if Psyche once experienced volcanic activity? At first, the idea sounds strange. When we think of volcanoes, we usually imagine molten rock erupting from beneath the surface of a planet. But Psyche may have been capable of something slightly different. If Psyche was once part of a larger protoplanet, its interior might have contained pockets of molten metal early in its history. As that molten material cooled and solidified, it could have forced its way toward the surface through cracks and fractures. Instead of lava flows made of rock, Psyche may have experienced metal-rich eruptions. Scientists sometimes refer to this possibility as ferrovolcanism, volcanic activity involving molten metal instead of molten rock. If such eruptions occurred, they might have created smooth metallic plains or strange surface structures formed by flowing metal that later solidified. Although we have never observed such processes directly, Psyche could provide the first opportunity to study them. Another mystery surrounding Psyche involves its color and reflectivity. Despite its potential metallic composition, Psyche does not shine brightly like polished metal. Instead, telescopic observations show that its surface appears relatively dark. This may seem surprising. Pure iron surfaces can be highly reflective, but over billions of years in space, surfaces undergo a process known as space weathering. Space weathering gradually alters the appearance of planetary surfaces. Tiny micrometeorites constantly bombard objects in space, melting small portions of the surface and depositing new material. At the same time, radiation from the sun slowly modifies the chemical structure of exposed minerals. On rocky asteroids, space weathering often darkens the surface and reduces its reflectivity. Something similar may be happening on Psyche. If the asteroid contains large amounts of metal, its surface may have developed a layer of microscopic damage from countless tiny impacts. These impacts could have roughened the metal and mixed it with dust and debris. Over billions of years, this process might have transformed what was once a brighter metallic surface into a darker, more muted landscape. This may explain why Psyche appears darker than some scientists originally expected. Another important factor is temperature. Psyche orbits the Sun at an average distance of about 450 million kilometers. At this distance, sunlight is much weaker than it is near Earth. Temperatures on Psyche are extremely cold, often falling far below freezing. In such conditions, any exposed metals would remain solid and brittle. Cracks and fractures formed by ancient impacts could remain frozen in place for billions of years. Unlike Earth, where erosion constantly reshapes the surface, Psyche has almost no processes capable of smoothing or renewing its landscape. There is no atmosphere, no wind, no flowing water, no active geology. Every crater, ridge, and fracture may have remained largely unchanged for billions of years. In other words, Psyche may be a time capsule. Its surface could preserve the scars of ancient collisions that occurred during the earliest stages of planetary formation. By mapping these craters and studying their distribution, scientists may be able to reconstruct the asteroid's violent history. But to truly understand Psyche's surface, telescopes alone are not enough. Even the most advanced observatories cannot reveal details smaller than a few kilometers across. To uncover the true nature of Psyche's terrain, scientists need to see it up close. That is where NASA's Psyche spacecraft comes in. When the spacecraft finally arrives at the asteroid, it will begin a detailed survey of Psyche's surface. Its instruments will measure the asteroid's composition, analyze its magnetic properties, and create high-resolution maps of its terrain. For the first time, humanity will see the surface of this mysterious metallic world in extraordinary detail. We will discover whether Psyche truly resembles the exposed core of a planet, a rugged metallic landscape shaped by billions of years of cosmic violence, or whether it holds even stranger surprises waiting to be revealed. Because in the asteroid belt, appearances can often be deceiving, and Psyche may still have many secrets left to uncover. If Psyche truly is one of the strangest objects in the asteroid belt, its story cannot be understood without looking at the violent environment that shaped it. The region between Mars and Jupiter may seem calm today, but billions of years ago, it was one of the most chaotic places in the solar system. In the earliest age of planetary formation, the asteroid belt was not simply a collection of scattered rocks. It was a crowded region filled with growing worlds. Thousands of planetesimals and protoplanets orbited the Sun there. Some of these bodies were large enough to reach hundreds of kilometers in diameter, and many of them were still actively colliding and merging. During this time, the solar system was still organizing itself. The planets we know today had not yet settled into stable orbits. Gravitational interactions between young planets constantly disturbed the motion of nearby objects. When orbits shifted, collisions became inevitable. And in space, collisions do not happen gently. Even relatively small asteroids can strike one another at speeds of tens of thousands of kilometers per hour. At those velocities, the energy released is enormous, far greater than anything produced by the largest nuclear explosions on Earth. When two bodies collide at such speeds, they can shatter completely. Entire worlds can be broken apart in minutes. Scientists believe that during the first few 100 million years of the solar system, this kind of violent destruction happened repeatedly. The asteroid belt may once have contained enough material to form another planet roughly the size of Mars, but the powerful gravity of nearby Jupiter prevented this from happening. Instead of merging into a single planet, objects in the asteroid belt were constantly pulled into unstable orbits. Jupiter's gravitational influence stirred the region like a cosmic blender. Every time an asteroid's orbit shifted slightly, the chances of collision increased. Over millions of years, these disturbances created a chain reaction of impacts. Large protoplanets smashed into each other. Smaller asteroids were shattered into fragments. Debris from one collision would spread throughout the belt, eventually crashing into other bodies and creating new impacts. The result was a long era of destruction that reshaped the entire region. Many of the objects that once existed in the asteroid belt no longer survive today. They were broken apart, scattered into smaller fragments, or ejected from the solar system entirely. Only a small fraction of the original bodies remain. Psyche may be one of those rare survivors, but surviving billions of years in such a dangerous environment would not have been easy. The surface of Psyche likely carries the scars of countless impacts that occurred throughout its history. Every crater on its surface tells part of that story. Large asteroids striking Psyche would have blasted enormous craters into its surface. Some of these impacts may have excavated material from deep beneath the surface, exposing new layers of metal or rock. Smaller impacts would have peppered the asteroid with thousands of smaller craters, gradually roughening its terrain. Over time, these collisions may have reshaped Psyche completely. If Psyche began as the metallic core of a larger protoplanet, its surface might originally have been relatively smooth, but billions of years of impacts would have transformed it into a rugged landscape filled with fractures, cliffs, and massive basins. Some impacts may even have been powerful enough to nearly destroy Psyche entirely. When two large bodies collide in space, the outcome depends on many factors: the size of the objects, their speed, the angle of impact, and their internal structure. In some cases, a collision simply creates a crater. In other cases, the impact energy is so great that the entire body shatters. If Psyche truly is metallic, its structure may have helped it survive impacts that would have destroyed weaker objects. Metal can absorb and distribute impact energy differently than rock. Instead of shattering instantly, a metal-rich body might deform or fracture while remaining largely intact. This property could explain why Psyche has survived while many other early protoplanets disappeared. But even if Psyche endured these collisions, they would still have left their marks. Large impacts could have created enormous basins tens of kilometers across. These basins might expose deeper layers of the asteroid, revealing clues about its internal composition. Some impacts may even have excavated material from beneath the metallic surface. If rocky mantle material still exists inside Psyche, these collisions could have brought it to the surface. This may explain why some observations suggest Psyche contains a mixture of metal and rock, rather than pure metal alone. Over billions of years, impacts from surrounding asteroids would have gradually mixed these materials together. Debris from collisions may have settled back onto the surface, forming layers of fragmented material. Tiny micrometeorites, grains of dust traveling at high speeds, would also have struck Psyche constantly. Each tiny impact may seem insignificant on its own, but over millions of years they can slowly grind and modify a surface. This process helps create the dusty regolith seen on many asteroids. But Psyche may behave differently. Because its surface may contain large amounts of metal, the material produced by impacts could be quite unusual. Instead of dusty rock, the debris may include tiny metallic fragments scattered across the terrain. These fragments could create a unique kind of regolith, a metallic soil formed by billions of years of impacts. The surface of Psyche might therefore be covered with a strange mixture of metallic grains, fractured rock, and ancient debris. But the asteroid belt did not remain equally violent forever. Over time, the number of large bodies in the region decreased. Each collision either destroyed objects or scattered them into new orbits. Gradually, the population of large impactors declined. As the solar system matured, the frequency of massive collisions began to drop. Today, the asteroid belt is far less crowded than it once was. Collisions still happen occasionally, but they are much rarer than during the early stages of planetary formation. For Psyche, this means that its most dramatic scars likely formed billions of years ago. The largest craters on its surface probably date back to the earliest era of the solar system, a time when collisions between protoplanets were common. By studying these craters, scientists may be able to estimate how old different regions of Psyche's surface are. In planetary science, the number of craters on a surface often reveals its age. A surface covered with many craters is usually very old because it has been exposed to impacts for a long time. A surface with fewer craters may be younger, possibly reshaped by geological processes. On Psyche, the crater record may reveal whether the asteroid's surface has changed significantly over time. If Psyche once experienced volcanic activity or internal heating, some regions might show signs of resurfacing. If not, its terrain may be among the oldest preserved landscapes in the solar system. But there is another possibility scientists are eager to investigate. What if some of Psyche's craters reveal evidence of its metallic interior? If a large impact penetrated deep enough, it might have exposed pure metal beneath the surface layers. Such regions could shine differently under sunlight, reflecting light in ways that telescopes could detect. These metallic exposures might provide the clearest evidence that Psyche truly is the core of a long-lost planet. For now, however, these ideas remain hypotheses. Without a spacecraft visiting Psyche directly, scientists cannot yet see its surface clearly enough to confirm them. But that situation will soon change. NASA's Psyche mission is designed to map the asteroid in unprecedented detail. Its cameras will capture high-resolution images of the surface. Its instruments will measure the composition of different regions, and its magnetometer will search for traces of ancient magnetic fields preserved in the asteroid's metal. All of these observations will help scientists reconstruct the history of Psyche. They may reveal which impacts shaped its terrain. They may uncover regions where metallic material lies exposed, and they may help determine whether Psyche truly began as the core of a protoplanet that was destroyed billions of years ago. If that is the case, then every crater on Psyche's surface becomes part of a much larger story, a story of cosmic violence, of worlds colliding and breaking apart, of ancient planetary fragments drifting through space for billions of years. And Psyche may be one of the most remarkable survivors of that era, a metallic relic from the chaotic age when the planets themselves were still being formed. From a distance, Psyche appears as a mysterious object drifting quietly through the asteroid belt. Its orbit is stable, its path predictable, and its faint light reflects calmly through telescopes on Earth. But beneath that quiet exterior lies one of the greatest scientific questions about this strange asteroid. What does Psyche actually look like inside? Understanding the internal structure of Psyche is essential to solving its biggest mystery. If it truly is the exposed core of a destroyed protoplanet, then its interior may be composed almost entirely of metal, primarily iron and nickel. Such a structure would be radically different from most asteroids. Typical asteroids are made of mixtures of rock, carbon-rich material, and sometimes ice. Many are not even solid objects at all. Instead, they are rubble piles, loose collections of fragments held together only by gravity. These rubble pile asteroids formed after collisions shattered larger bodies. Their pieces later reassembled into irregular shapes with large internal voids and weak structures. Psyche, however, appears to be different. Its density suggests that it may be far more solid than most asteroids. If large portions of Psyche are metallic, then its interior might be compact and strong, closer to the structure of a planet than a loose asteroid. This idea raises an extraordinary possibility. Psyche might contain the remnants of a planetary core. To understand why this matters, we need to consider how planetary cores form in the first place. During the early stages of planetary formation, growing protoplanets generate tremendous heat. This heat comes from several sources: gravitational compression, radioactive decay, and the energy released during impacts. As temperatures rise, the interior of the young world begins to melt. When this happens, materials start to separate according to their density. Heavy elements like iron and nickel sink toward the center of the body, while lighter silicate rocks remain closer to the surface. Over time, the interior becomes layered. At the center lies a dense metallic core. Above it lies the mantle, made mostly of rocky minerals. And at the outermost layer sits the crust, the thin shell that forms the planet's surface. This layered structure is a hallmark of differentiated planetary bodies: Earth, Mars, Venus, and Mercury. All possess cores formed through this process, but normally, these cores remain buried deep beneath thousands of kilometers of rock. Even with the most advanced technology, humans cannot directly access Earth's core. The deepest drill holes ever made reach only about 12 kilometers beneath the surface, barely scratching the outer crust. The core itself lies nearly 3,000 kilometers below us. Because of this, scientists study planetary cores indirectly using seismic waves, magnetic fields, and gravitational measurements. But Psyche could provide something completely different. If it truly represents the metallic core of a destroyed protoplanet, then it may expose core material directly on its surface. This would give scientists the first opportunity to study planetary core material without having to dig through an entire planet. But the situation may not be quite that simple. Recent observations suggest that Psyche might not be made entirely of metal. Instead, it may contain a mixture of metallic and rocky components. There are several ways this could happen. One possibility is that Psyche was originally a differentiated protoplanet with a metallic core and rocky mantle. Later, a massive collision stripped away most of the mantle, but not all of it. In this scenario, Psyche today would represent a partially exposed core, still containing fragments of the original rocky layers. Another possibility is that Psyche formed from multiple metallic fragments produced by ancient collisions. Over time, gravity could have pulled these fragments together, forming a new body composed largely of metal. This type of formation would create an asteroid with a metallic composition, but without the perfectly layered structure of a planetary core. There is also the possibility that Psyche underwent additional geological processes during its early history. If the asteroid once contained pockets of molten metal beneath its surface, these materials might have slowly cooled and solidified over time. As they cooled, the metal could have contracted and fractured, creating networks of cracks throughout the interior. These fractures might still exist today, influencing how Psyche responds to impacts and gravitational forces. Understanding this internal structure is one of the main goals of the NASA Psyche mission. When the spacecraft arrives at the asteroid, it will carry several instruments designed to study the interior indirectly. One of the most important tools is the spacecraft's magnetometer. This instrument measures magnetic fields surrounding the asteroid. Why does this matter? Because if Psyche once had a molten metallic core, it may have generated a magnetic field in the past. On Earth, the movement of molten iron inside the outer core creates our planet's magnetic field through a process known as the geodynamo. This magnetic field protects Earth from harmful solar radiation and shapes the behavior of charged particles in space. If Psyche once had a similar molten interior, it might have produced a magnetic field billions of years ago. Even though that field would no longer exist today, traces of it might still be preserved in the asteroid's metallic minerals. When molten metal cools in the presence of a magnetic field, the atoms within it can align in ways that permanently record the direction of that field. By measuring these magnetic signatures, scientists could determine whether Psyche once generated its own magnetic field. If such evidence is found, it would strongly support the idea that Psyche was once part of a much larger, differentiated body. Another instrument on the spacecraft will measure Psyche's gravity field. By carefully tracking how the spacecraft's orbit changes as it circles the asteroid, scientists can map the distribution of mass within Psyche. If the asteroid has a dense metallic core surrounded by lighter materials, this gravity data will reveal it. But if Psyche's interior is more uniform, or if it contains large voids, the gravity measurements will show that as well. These observations will help scientists determine whether Psyche is a solid metal body, a layered structure, or a mixture of materials. Another fascinating possibility is that Psyche might contain hidden geological structures beneath its surface. If the asteroid once cooled from a molten state, it could have developed internal patterns similar to those seen in slowly solidifying metals on Earth. In metallurgy, when molten metal cools, crystals can form in organized patterns. These structures can influence the strength and appearance of the metal. If Psyche experienced similar processes billions of years ago, its interior might contain enormous crystalline metallic formations. Of course, detecting such structures from orbit would be extremely difficult, but even indirect measurements might reveal hints about how the asteroid formed and cooled. The internal structure of Psyche may also help explain its unusual shape. Unlike perfectly spherical planets, most asteroids have irregular shapes because their gravity is too weak to pull them into smooth spheres. Psyche itself appears somewhat irregular, although its exact shape remains uncertain. A metallic interior could influence how the asteroid responds to gravitational forces and impacts. If Psyche is more solid and rigid than typical asteroids, it might preserve sharper edges and more dramatic surface features. In contrast, rubble pile asteroids often appear more rounded because their loose materials shift over time. These structural differences may become clearer once the spacecraft begins mapping Psyche in detail. For now, however, much about Psyche's interior remains a mystery. Is it truly the metallic core of a destroyed planet? Or is it a complex mixture of metal and rock formed through countless collisions? The answer may reveal new insights into the early history of the solar system. Because Psyche is not just an asteroid, it may be a relic from a time when entire worlds were still forming and sometimes being torn apart. Hidden within its metallic interior could be the story of a lost protoplanet that once existed billions of years ago, a world whose outer layers vanished long ago, leaving behind only its dense metallic heart. And soon, humanity will finally begin to explore that heart up close. The secrets buried inside Psyche may reshape everything we know about how planets are built and how some of them are destroyed. For more than a century after its discovery, Psyche remained one of the most mysterious objects in the asteroid belt. Astronomers could observe its orbit and measure the faint light reflecting from its surface, but its true nature remained hidden behind distance and uncertainty. Was Psyche truly made of metal? Was it the exposed core of a destroyed planet? Or was it something else entirely? These questions could not be answered from Earth alone. To understand Psyche, scientists would need to do something far more ambitious: travel there. Reaching an asteroid in the distant asteroid belt is no small task. Psyche orbits the Sun at an average distance of about 450 million kilometers from our planet. Any spacecraft attempting the journey must travel for years, navigating complex gravitational paths across the solar system. But the scientific potential was too extraordinary to ignore. In 2017, NASA officially selected a mission designed specifically to explore this strange metallic asteroid. The mission was simply named Psyche. Its goal is historic. For the first time in human history, a spacecraft will visit what may be the exposed core of a planetary body. If Psyche truly represents the metallic heart of a destroyed protoplanet, this mission could provide the first direct glimpse into the interior of a world, something scientists have never been able to study before. The spacecraft itself represents decades of technological progress. Unlike earlier missions that relied on chemical rockets for propulsion, the Psyche spacecraft uses solar electric propulsion, one of the most efficient methods of traveling long distances in space. Instead of burning fuel in explosive bursts, solar electric propulsion works in a completely different way. Large solar panels capture energy from the sun and convert it into electricity. That electricity powers engines known as Hall effect thrusters. These thrusters accelerate charged particles of xenon gas to extremely high speeds, producing a gentle but continuous thrust. The force produced by these engines is tiny, far weaker than the thrust of a conventional rocket. But because the engines can operate continuously for months or even years, they gradually build up tremendous velocity. Over long distances, this method is incredibly efficient. It allows spacecraft to travel farther while carrying far less fuel. The Psyche spacecraft uses two enormous solar arrays stretching outward like wings. Even at the vast distance of the asteroid belt, where sunlight is far weaker than near Earth, these panels generate enough power to keep the engines running. With this propulsion system, the spacecraft will slowly spiral outward from the inner solar system, adjusting its trajectory through carefully planned maneuvers. But propulsion is only part of the challenge. To study Psyche properly, the spacecraft must carry a set of sophisticated scientific instruments designed to examine the asteroid in extraordinary detail. One of the most important instruments aboard the spacecraft is the multispectral imager. This system consists of high-resolution cameras capable of capturing detailed images of Psyche's surface. These cameras will photograph the asteroid across different wavelengths of light, allowing scientists to analyze variations in surface composition. By studying the brightness and color of different regions, researchers can identify areas rich in metal, rock, or other materials. These images will also reveal the asteroid's craters, cliffs, ridges, and basins in far greater detail than any telescope could achieve from Earth. For the first time, humanity will see the surface of this mysterious metallic world up close. Another critical instrument aboard the spacecraft is the gamma ray and neutron spectrometer. This instrument measures the energy released by radioactive elements and interactions between cosmic rays and surface materials. By analyzing these signals, scientists can determine which elements are present within the asteroid. If Psyche is rich in iron, nickel, or other metals, this instrument will detect them. It will also help identify the presence of lighter elements such as silicon, oxygen, or hydrogen, which could indicate the presence of rocky materials or even water-bearing minerals. These measurements will provide one of the clearest pictures yet of Psyche's chemical composition. But perhaps the most intriguing instrument aboard the spacecraft is the magnetometer. This device measures magnetic fields surrounding the asteroid. Why is this important? Because if Psyche truly formed as the core of a protoplanet, it may once have generated a magnetic field billions of years ago. On Earth, the motion of molten metal inside the outer core creates our planet's magnetic field through a process known as the geodynamo. If Psyche once had a molten metallic interior, similar processes might have occurred there long ago, although that ancient magnetic field would have faded billions of years ago. Traces of it may still be preserved within the asteroid's metal. When molten metal cools in the presence of a magnetic field, it can record the direction of that field in its internal structure. By measuring these faint magnetic signatures, scientists may be able to determine whether Psyche once possessed a magnetic field of its own. Such a discovery would provide powerful evidence that Psyche was once part of a much larger planetary body. Another instrument aboard the spacecraft will help scientists understand Psyche's internal structure. This is done through careful measurements of the asteroid's gravity field. As the spacecraft orbits Psyche, its trajectory will be influenced by variations in the asteroid's gravity. By analyzing these tiny changes in motion, scientists can map the distribution of mass within the asteroid. If Psyche has a dense metallic interior, these gravity measurements will reveal it. If its interior contains voids or mixtures of rock and metal, that information will also become clear. Together, these instruments will allow scientists to study Psyche in ways that were once impossible. But the mission carries another remarkable technological experiment as well. The Psyche spacecraft includes a device known as the Deep Space Optical Communication System, or DSOC. Traditionally, spacecraft communicate with Earth using radio signals. While effective, radio communications can be slow when transmitting large amounts of data across vast distances. The DSOC experiment tests a new method: laser communication. Using powerful lasers, the spacecraft will transmit data back to Earth using beams of light rather than radio waves. Because laser signals can carry much more information than radio signals, this technology could dramatically increase the amount of scientific data future missions can send back from deep space. If successful, laser communication may become a standard feature of future interplanetary exploration. But long before the spacecraft begins sending back its discoveries, it must first complete a journey lasting several years. After launch, the spacecraft will travel through the inner solar system, gradually adjusting its trajectory. At one point, it will perform a gravity assist maneuver near Mars. During this maneuver, the spacecraft will use the gravity of Mars to gain additional speed and redirect its path toward the asteroid belt. Gravity assists are one of the most elegant techniques used in space exploration. Instead of using fuel to accelerate, spacecraft borrow energy from the motion of planets themselves. This allows them to reach distant destinations with far greater efficiency. After completing its gravity assist, the Psyche spacecraft will continue its long journey outward. Eventually, it will arrive at its destination. When it finally reaches the asteroid, the spacecraft will begin a carefully planned sequence of orbital operations. Unlike some missions, that briefly fly past their targets, Psyche will enter orbit around the asteroid. Over many months, the spacecraft will gradually move into lower and lower orbits, collecting increasingly detailed data about the asteroid's surface and interior. During these orbits, scientists will construct detailed maps of Psyche's terrain, composition, and gravitational structure. Every new image and measurement will help answer the questions that have surrounded this object for decades. Is Psyche truly the metallic core of a destroyed protoplanet? Or does it represent something entirely different? The answers could reshape our understanding of how planets form and how they sometimes die. Because Psyche may not simply be another asteroid drifting quietly through space. It may be the exposed heart of a lost world. A world that formed billions of years ago during the earliest stages of planetary creation. A world that was shattered by catastrophic collisions in the chaotic youth of the solar system. And now, after drifting silently through space for billions of years, that metallic heart is finally about to be explored by humanity for the first time. What we discover there may reveal secrets about the deep interiors of planets, secrets that have remained hidden since the dawn of the solar system itself. If Psyche truly is one of the strangest objects in the asteroid belt, then its surface may hold the clearest clues to its mysterious past. For scientists, the terrain of an asteroid is more than just a landscape. Every crater, ridge, and fracture is a record of ancient events, a geological archive preserving billions of years of history. On Earth, erosion constantly reshapes the surface. Wind, rain, rivers, and tectonic activity gradually erase the scars of ancient impacts. Over millions of years, entire mountain ranges can rise and disappear. The geological record is constantly rewritten. But Psyche is very different. Out in the asteroid belt, there is almost nothing that can erase the marks left by time. There is no atmosphere, no wind, no flowing water, no shifting tectonic plates. Once a feature forms on the surface of an asteroid, it can remain there for billions of years. This means that Psyche's surface may preserve one of the oldest landscapes in the solar system. But what exactly might that landscape look like? Most asteroids have surfaces that are covered with thick layers of regolith, loose material formed by countless impacts over billions of years. This regolith is made of dust, broken rock, and debris produced when meteorites strike the asteroid. On a typical rocky asteroid, the ground might resemble a field of shattered stone mixed with fine powdery dust. But Psyche may be something entirely different. Because if the asteroid truly contains large amounts of metal, then its surface materials may behave in ways that scientists have never observed before. Metal responds to impacts very differently than rock. When a meteorite strikes rock, material tends to shatter and crumble easily. But metal can deform, fracture, or melt depending on the energy of the impact. This could produce unusual terrain features that are not seen on typical rocky asteroids. For example, some impacts might create sharp metallic ridges or fractured surfaces where the metal cracked under extreme pressure. Other impacts might partially melt the metal before it quickly cooled again in the vacuum of space, forming smooth metallic flows that later hardened into place. These processes could create a landscape that looks unlike anything else in the solar system. Instead of dusty plains and broken rock, Psyche's surface may contain metallic cliffs, jagged ridges, and enormous impact basins carved into iron-rich terrain. But even if Psyche is metallic, its surface is unlikely to be smooth or shiny like polished metal. Over billions of years, the asteroid has been exposed to space weathering. Space weathering is the gradual process by which the surface of an airless body is altered by constant exposure to the harsh environment of space. Tiny micrometeorites continuously strike the surface at high speeds, vaporizing small amounts of material and scattering debris across the landscape. At the same time, radiation from the sun slowly modifies the chemical structure of exposed minerals. These processes gradually darken and roughen the surface of many asteroids. If Psyche contains large amounts of metal, similar processes may have altered its appearance over time. Instead of shining brightly like a metallic object, Psyche's surface may have developed a darker coating formed by microscopic impacts and radiation damage. This could explain why telescopic observations show Psyche as relatively dark compared to what scientists once expected. Another fascinating possibility is that Psyche's surface may contain remnants of volcanic activity, but not the kind of volcanoes we see on Earth. On rocky planets, volcanic eruptions involve molten rock rising from beneath the surface. This molten material, known as magma, flows across the surface as lava before cooling and solidifying. But if Psyche once had a molten metallic interior, a similar process might have occurred using molten metal instead of molten rock. Scientists refer to this hypothetical process as ferrovolcanism. During the early history of the asteroid, pockets of molten iron could have been forced upward through cracks in the surface. When this molten metal reached the cold vacuum of space, it would have cooled and solidified rapidly. Such eruptions might have created smooth metallic plains or unusual flow patterns across the surface. Although no spacecraft has ever observed ferrovolcanism directly, Psyche may provide the first opportunity to study such processes. But volcanic activity is only one possibility. The surface of Psyche may also contain enormous impact basins formed by collisions with other asteroids. The asteroid belt is a dangerous place. Although the objects within it are spread across a vast region of space, gravitational disturbances constantly shift their orbits. When two asteroids cross paths, collisions can occur at tremendous speeds. Some impacts may have been powerful enough to excavate material from deep inside Psyche. If the asteroid truly represents the exposed core of a protoplanet, these impacts may have revealed layers of pure metal beneath the surface. Other impacts may have scattered fragments across the asteroid, creating a mixture of metal and rocky debris. These collisions may also have produced towering cliffs and fractured terrain. Large impacts can generate enormous shock waves that travel through the interior of an asteroid. When these waves reach the surface, they can create long fractures stretching across the landscape. Some asteroids display enormous cracks hundreds of kilometers long. If similar fractures exist on Psyche, they could provide clues about the asteroid's internal structure. Another interesting feature scientists hope to observe is the distribution of boulders across Psyche's surface. On many asteroids, large boulders are scattered across the terrain after impacts break apart sections of the crust. If Psyche contains both rock and metal, some of these boulders may be metallic fragments exposed by ancient collisions. Such metallic boulders would be unlike anything seen on other asteroids. They could provide direct evidence of Psyche's unusual composition. Temperature may also play an important role in shaping the surface. Because Psyche has no atmosphere, its temperature varies dramatically, depending whether a region is facing the sun or turned toward deep space. During the day, sunlight can heat the surface significantly, but during the long nights, temperatures plunge to extremely cold levels. These repeated heating and cooling cycles may gradually weaken surface materials over time. Even metal can expand and contract under such conditions, potentially causing cracks and fractures to grow slowly across the asteroid surface. Over billions of years, these thermal stresses could have helped shape Psyche's rugged terrain. But despite all of these processes, Psyche's surface may still remain remarkably ancient. Unlike planets with active geology, Psyche likely lacks the internal energy needed to reshape its landscape. Most of the features visible on its surface may have formed billions of years ago during the chaotic era when the solar system was still forming. In other words, Psyche may preserve a frozen record of planetary history. Every crater may represent an ancient collision. Every fracture may tell the story of internal stresses from long ago. Every metallic ridge may be the remnant of a catastrophic impact that reshaped the asteroid. But until recently, scientists could only speculate about these possibilities. From Earth, Psyche appears as little more than a small point of light. Even the largest telescopes cannot resolve its surface features clearly enough to answer these questions. That is why the arrival of NASA's Psyche spacecraft will be so important. When the spacecraft finally reaches the asteroid, it will begin mapping the surface in extraordinary detail. Its cameras will capture high-resolution images revealing the shapes of craters, cliffs, and ridges. Its spectrometers will analyze the composition of different regions, identifying where metal or rock is most abundant. And its instruments will measure the asteroid's magnetic properties and internal structure. Together, these observations will reveal what Psyche's strange surface truly looks like. For the first time, humanity will see whether this mysterious asteroid really resembles the exposed metallic heart of a lost planet. And if that is the case, Psyche may provide something no other object in the solar system can offer: a direct window into the hidden interiors of worlds, a place where the secrets of planetary cores are no longer buried thousands of kilometers underground, but exposed directly beneath the cold light of the distant sun. For decades, the asteroid known as Psyche has existed mostly as a mystery, shaped by distant observations and careful speculation. From millions of kilometers away, astronomers have measured its brightness, estimated its density, and studied the way it reflects sunlight. Radar signals have bounced off its surface, hinting at unusual metallic properties. Telescopes have revealed faint clues about its composition, but none of those observations can fully answer the most important question: what exactly is Psyche? Is it truly the exposed core of a destroyed planet? Is it a strange metallic relic from the earliest days of the solar system? Or is it something scientists have never encountered before? For the first time in history, humanity is about to visit this strange world directly. And when the spacecraft arrives, the discoveries it makes could completely change our understanding of how planets form. A world we've never seen. Up close. The spacecraft on its way to Psyche is carrying a collection of instruments designed to do something no mission has done before: study a metal world in detail. Until now, nearly every asteroid mission has explored rocky bodies. NASA's OSIRIS-REx visited the carbon-rich asteroid Bennu. Japan's Hayabusa missions studied rubble pile asteroids like Itokawa and Ryugu. But Psyche is different. If current theories are correct, Psyche could be composed largely of nickel-iron metal, the same material found deep inside Earth's core. If that's true, this asteroid may be the first exposed planetary core humanity has ever examined. And that means the mission isn't just exploring an asteroid. It's exploring something much more extraordinary, a fragment of a world that no longer exists. The first close images, one of the most exciting moments of the mission, will come when the spacecraft finally sends back the first high-resolution images of Psyche's surface. Right now, even the best telescopes can only show Psyche as a blurry point of light. Astronomers know its shape roughly resembles a slightly irregular potato. But beyond that, the details remain hidden. When the spacecraft arrives, that will change instantly. For the first time, scientists will see the true shape of Psyche, the craters and ridges covering its surface, the distribution of bright and dark regions, the geological history recorded in its terrain. These images will reveal whether Psyche looks like a typical asteroid or something completely different. If it really is metal-rich, its surface may appear smoother and more reflective than rocky asteroids. But there is also a possibility that it looks far stranger, because metal worlds may evolve in ways scientists have never studied before. The mystery of Psyche's craters. Impact craters are one of the most important clues to understanding any planetary body. They record billions of years of collisions. They tell scientists how hard the surface is. They reveal how materials behave under extreme impacts. On rocky asteroids, craters form in fairly predictable ways. The impacts excavate material, throwing debris outward and leaving circular scars behind. But what happens when a meteor strikes a metal surface? That question has never truly been answered. If Psyche is metallic, its craters might look completely different from those on rocky asteroids. Instead of pulverizing easily, a metal surface could deform in unusual ways. Impacts might produce shallow dents rather than deep craters, sharp-edged scars, strange fracture patterns. Some scientists have even suggested that large impacts might leave smooth basins, where molten metal once briefly flowed before cooling again. If such features exist, they would reveal something remarkable. They would show how planetary cores behave when exposed to the vacuum of space. Mapping Psyche's surface beyond images, the spacecraft will create detailed maps of Psyche using a powerful multispectral imager. This instrument will analyze the way Psyche reflects light at different wavelengths. By studying those reflections, scientists can identify the materials present on the asteroid surface. They will be searching for nickel-iron metal, silicate minerals, oxidized metals, possible traces of volcanic activity. If Psyche formed as a planetary core, the surface could contain a mix of materials. Some of these may have come from the original planet. Others may have arrived later, delivered by countless asteroid impacts over billions of years. Mapping these materials will help scientists reconstruct Psyche's history. It may reveal whether Psyche is truly the remnant of a shattered world, or simply a rare type of metallic asteroid. Measuring Psyche's gravity. Another crucial experiment involves measuring Psyche's gravitational field. Even small differences in gravity can reveal important clues about what lies beneath the surface. By carefully tracking the spacecraft's orbit around Psyche, scientists can detect tiny changes in its motion. These variations allow them to map how mass is distributed inside the asteroid. This could answer several key questions. Is Psyche solid metal all the way through? Or does it contain pockets of rock mixed within the metal? Perhaps its interior is fractured and porous. Or perhaps it hides a dense, intact metallic core surrounded by debris from ancient impacts. The gravitational measurements will help scientists understand Psyche's internal structure, and that structure will reveal how the asteroid formed billions of years ago. The magnetic field. Mystery. One of the most intriguing instruments aboard the spacecraft is a magnetometer. This device measures magnetic fields. Why is that important? Because planetary cores often generate powerful magnetic fields. Earth's magnetic field, for example, is created by the movement of molten iron inside its core. If Psyche once belonged to a larger planet, its metallic core might have once produced a similar magnetic field. Even though that field would no longer exist today, traces of it could still remain frozen into Psyche's metal. If the spacecraft detects ancient magnetization, it would be an extraordinary discovery. It would mean Psyche once belonged to a fully formed planet with a molten, dynamic interior. In other words, Psyche would truly be the exposed heart of a lost world. Searching for volcanic history. It might seem strange to imagine volcanoes on a metal world, but if Psyche formed as a planetary core, it may once have been partially molten. In the early solar system, heat from radioactive elements and violent impacts could have melted large amounts of metal. Under those conditions, molten iron could have erupted onto the surface in a process known as ferrovolcanism. Instead of lava made of rock, these eruptions would have produced flows of liquid metal. Scientists are not sure whether such events ever occurred on Psyche, but the spacecraft's instruments will search for signs of them. If metallic lava flows exist, they could appear as smooth plains, long frozen channels, metallic ridges formed by cooling flows. Finding such features would reveal that Psyche was once a far more active world than anyone expected. Signs of catastrophic destruction. If Psyche really is the exposed core of a planet, then something extraordinary must have happened long ago. The outer layers of rock that once surrounded the core would have been blasted away by immense collisions. These impacts must have been violent beyond imagination. The spacecraft's observations may reveal evidence of those ancient disasters scientists will look for. Massive impact basins, giant fractures across the surface, regions where large chunks of the asteroid appear missing. Such features could tell the story of Psyche's destruction. They could reveal how a planet lost its outer layers and left only its metallic heart behind. Unexpected discoveries. Of course, History has shown that space missions rarely discover only what scientists expect. Often, the most important discoveries are the ones no one predicted. When Voyager flew past Uranus and Neptune, it revealed bizarre tilted magnetic fields and mysterious moons. When New Horizons visited Pluto, it discovered enormous nitrogen glaciers and mountains made of ice. And when spacecraft studied asteroids like Bennu and Ryugu, they found surfaces far rougher and more complex than anyone imagined. Psyche may hold surprises of its own. Perhaps its surface will contain strange metallic formations. Perhaps it will reveal unusual mineral structures created by billions of years of space weathering. Or perhaps it will show that Psyche is not a planetary core at all. Instead, it might turn out to be something even stranger, a type of object scientists have never seen before. Rewriting the story of planet formation. The most profound discoveries from Psyche may not come from its surface features. They may come from what Psyche reveals about the birth of planets themselves. In the early solar system, countless protoplanets were forming at the same time. Some survived to become the worlds we know today. Others were destroyed in violent collisions. Fragments of those destroyed worlds may still orbit the Sun. If Psyche truly is the exposed core of one of those lost planets, it would provide direct evidence of that chaotic era. Studying Psyche could help scientists understand how planets differentiate into layers, how metallic cores form, how violent impacts shape the solar system. In a sense, Psyche may be a fossil from the time when planets were still being built, a window into Earth's own core. Perhaps the most fascinating aspect of the mission is that Psyche may help us understand something much closer to home. Earth's core lies more than 2,900 kilometers beneath our feet. No drill will ever reach it. Scientists can only study it indirectly using seismic waves. But if Psyche truly represents an exposed planetary core, it offers something extraordinary. It allows scientists to study core material directly. The metal inside Psyche may resemble the metal deep inside Earth. By analyzing its composition and structure, scientists may learn new things about the hidden interior of our own planet. In that sense, exploring Psyche may be like opening a window into Earth's deepest secrets. The moment of arrival. Years after launch, the spacecraft will finally approach Psyche. At first, the asteroid will appear as a faint point of light, growing slowly brighter. Then its shape will begin to emerge. Craters, ridges, and metallic landscapes will come into view. For the first time in human history, a world made largely of metal will stand before us. A world formed more than 4 billion years ago during the violent birth of the solar system. And in that moment, scientists will begin to answer the questions that have surrounded Psyche for decades. Is it truly the exposed core of a lost planet? Or is it something even stranger? The answer may transform our understanding of how worlds are born. But even before those answers arrive, one thing is already certain. Psyche is not just another asteroid. It is a relic from a forgotten chapter of cosmic history, a chapter written when planets were still forming, when worlds were colliding, and when the solar system was far more chaotic than it is today. Soon, we will finally see what remains of that ancient time, and Psyche may reveal secrets that have been hidden since the beginning of our solar system. For thousands of years, humans have looked up at the night sky and wondered what lies beyond the tiny points of light scattered across the darkness. Every star, every planet, every distant object has carried a story waiting to be uncovered. Over time, telescopes revealed moons around other worlds, spacecraft revealed landscapes beyond imagination, and slowly, piece by piece, humanity began to understand how the solar system came to be. But some mysteries have remained stubbornly out of reach. Among them is a strange object orbiting quietly in the asteroid belt between Mars and Jupiter, a world that reflects sunlight differently from most asteroids, a world whose density hints at something unusual beneath its surface, a world that may not be a typical asteroid at all. That world is Psyche. For decades, Psyche has existed only as a distant curiosity. Astronomers have studied it from afar, bouncing radar waves off its surface and analyzing the faint light it reflects toward Earth. Each observation has added another clue to the puzzle. But clues are not the same as answers. To truly understand Psyche, humanity had to do something it had never done before. We had to go there. The long journey across the solar system. Reaching Psyche is not a simple task. The asteroid orbits the Sun nearly 3 times farther from Earth than our planet orbits the Sun itself. It lies deep within the asteroid belt, a vast region filled with millions of rocky remnants left over from the formation of the solar system. To reach that distant region, the spacecraft must travel for years, following a carefully planned trajectory that uses gravity and precise navigation to guide it across millions of kilometers. During its journey, the spacecraft slowly closes the distance between itself and Psyche. At first, the asteroid is invisible, lost in the glare of distant stars. Then, gradually, a faint point appears. Day by day, that point grows brighter. Eventually, the spacecraft's cameras begin to detect something more than a dot of light. A small, irregular shape appears against the blackness of space. For the first time in human history, we begin to see Psyche not as an astronomical object, but as a world. First contact with a metal world. As the spacecraft approaches closer, the details sharpen. What once appeared as a single speck now reveals a complex landscape. Cratered regions stretch across the surface. Massive ridges cast long shadows across metallic plains. Some areas shine brightly, reflecting sunlight with unusual intensity, while others appear darker and rougher. Scientists watching the incoming data begin to notice something immediately. Psyche does not look like most asteroids. Rocky asteroids often resemble piles of rubble loosely held together by gravity. Their surfaces are chaotic fields of broken stones and dust. Many are so loosely packed that a spacecraft could almost sink into them. But Psyche may appear far more solid. If the asteroid truly contains large amounts of metal, its surface may look denser and more coherent, perhaps even smoother in some places. The first close images could reveal something remarkable, a world shaped not only by impacts, but by metal itself. The language of craters. One of the first scientific tasks will be studying Psyche's craters. Craters are like time capsules. Every impact leaves behind evidence about the asteroid's history. On rocky surfaces, impacts shatter the ground, ejecting debris outward and leaving deep circular pits. But metal behaves differently from rock. a high-speed collision with a metal surface could create unusual formations. Instead of pulverizing easily, the metal may deform or fracture in ways scientists have never observed on planetary bodies. The spacecraft's cameras may reveal craters that are shallower than expected, with sharp rims and unusual shapes. Some impacts might even appear as large dents in the metallic crust, where the force of the collision compressed the surface instead of breaking it apart. Each crater will tell a story about Psyche's past, a history written in impacts that stretch back billions of years. Reading the surface. Like a map beyond craters, scientists will study the asteroid's entire surface as if it were a giant historical record. Bright areas may indicate exposed metal reflecting sunlight strongly. Darker regions may contain mixtures of rock and metal, or perhaps material delivered by ancient asteroid impacts. The spacecraft's instruments will analyze these areas in detail, identifying the chemical fingerprints of different elements: nickel, iron, silicates, oxidized minerals. Each discovery will reveal more about Psyche's origin. If large regions consist mostly of metal, that would strengthen the idea that Psyche represents the exposed core of a destroyed planet. But if rock dominates the surface, the story may be more complicated. Psyche could turn out to be a hybrid world, containing both metal and stone in unexpected combinations. Listening to gravity. While cameras study the surface, another experiment unfolds quietly in the background. The spacecraft's orbit around Psyche will be monitored with incredible precision. Tiny variations in its path will reveal subtle changes in the asteroid's gravitational pull. Those changes allow scientists to map how mass is distributed inside the asteroid. If Psyche is a solid chunk of metal, its gravity will behave differently than if it contains a fractured interior filled with empty spaces. The gravitational data could reveal hidden structures beneath the surface, dense metallic cores, large internal cavities, or complex layers created during Psyche's violent past. It is almost like performing a medical scan of an alien world, searching for a fossil magnetic field. One of the most exciting discoveries the mission could make involves magnetism. Planetary cores often generate magnetic fields. Earth's magnetic field, for example, is created by the movement of molten metal inside its core. If Psyche once belonged to a larger planet, its core might have once produced a similar magnetic field. Although that field would no longer exist today, the metal within Psyche could still preserve traces of it. The spacecraft's magnetometer will search for these ancient signals. If they are found, they would confirm something extraordinary. They would prove that Psyche was once part of a fully formed planet with an active molten core. In other words, Psyche would truly be the heart of a lost world. Signs of an ancient catastrophe. If Psyche was once the core of a larger body, then something must have destroyed that world. The early solar system was a violent place. Young planets collided with each other in massive impacts that reshaped entire regions of space. Some of those collisions were powerful enough to strip away the outer layers of a planet, leaving only its metallic center behind. Scientists believe Psyche may be the survivor of such an event. The spacecraft may find enormous scars across its surface, gigantic basins created by ancient impacts, deep fractures where the asteroid's crust once cracked under immense forces. These features could reveal the moment when Psyche's original world was shattered, a catastrophic collision that removed its rocky mantle and exposed its metal core. Unexpected landscapes. Even with all these theories, there is a strong possibility that Psyche will surprise scientists. Space exploration has a long history of revealing landscapes no one predicted. When spacecraft first visited Saturn's moon Enceladus, they discovered massive plumes of water erupting from its icy surface. When Pluto was explored for the first time, it revealed glaciers made of frozen nitrogen flowing slowly across its plains. And when asteroids like Bennu and Ryugu were studied closely, scientists discovered surfaces far rougher than expected. Psyche could hold similar surprises. Perhaps it will contain towering metallic cliffs. Perhaps its surface will show patterns created by billions of years of space weathering. Or perhaps it will reveal geological structures that have never been seen anywhere else in the solar system. A relic from the birth of worlds. What makes Psyche so important is not just its unusual composition. It is what Psyche represents. This asteroid may be a fragment left over from the earliest era of planetary formation. More than 4.5 billion years ago, the solar system was filled with thousands of protoplanets. These young worlds collided repeatedly, merging together or tearing each other apart. Some of those collisions created the planets we know today. Others destroyed entire worlds. If Psyche truly is an exposed planetary core, it would be one of the only surviving pieces of that ancient chaos. Studying it would be like holding a fossil from the time when planets were still being built. A window into Earth's hidden interior. There is another reason Psyche fascinates scientists. The metal believed to dominate its structure is very similar to the metal that forms the core of Earth. But Earth's core lies nearly 3,000 kilometers beneath the surface. No human technology can reach it. Scientists can only study it indirectly through seismic waves and computer models. Psyche may offer a rare opportunity. If its interior truly resembles a planetary core, studying it could reveal information about the hidden center of our own planet, the structure of metallic cores, the way they cool and solidify, the way magnetic fields form. In a sense, Psyche could become the closest thing we have to a direct sample of Earth's deepest interior, humanity's expanding frontier. The exploration of Psyche represents something larger than the study of a single asteroid. It is part of a long tradition of exploration that has slowly pushed the boundaries of human knowledge outward. Centuries ago, explorers crossed oceans to map continents unknown to them. Later, scientists sent telescopes into space to study distant galaxies. Today, spacecraft travel millions of kilometers to visit worlds no human has ever seen. Each mission expands the map of our solar system. Each discovery reminds us how much there is still left to learn. Psyche is one more step in that journey. The moment of revelation. When the spacecraft finally settles into orbit around Psyche, a new chapter in planetary science will begin. Day after day, new data will arrive. Images, measurements, magnetic readings, gravity maps. Slowly, the mystery that has surrounded Psyche for decades will begin to unravel. Scientists will piece together the asteroid story, how it formed, what it is made of, and whether it truly is the exposed core of a destroyed world. The answers may take months or even years to fully understand. But one thing is certain. When those answers finally arrive, they will reveal something about the earliest history of the solar system, a history written in collisions, molten metal, and the birth of planets. A silent world, with an ancient story Psyche, has orbited the Sun for billions of years, silent and unchanged. It has witnessed the entire history of the solar system, the formation of planets, the extinction of worlds, the emergence of life on Earth, and the moment when intelligent beings began looking outward into space. Soon, those beings will finally reach Psyche, and when they do, they will stand before one of the most unusual objects ever discovered, a metal world drifting through the darkness, a relic from the violent birth of the solar system, a survivor from a time when planets were still forming and worlds were still breaking apart. And in its silent metallic surface, Psyche may hold the answers to questions that scientists have been asking for generations. Questions about how planets form, how worlds die, and how the solar system we call home came to be. The journey to Psyche is almost complete. Now, all that remains is to see what secrets this ancient world is ready to reveal.